2 is all about graphing. So we're going to be plotting points and looking at lines in 2-1. 2-2 will be looking at circles. 2-3 will be looking at lines and how to find the equations. And then the later part of chapter 2, we'll be looking at different curves. We won't be looking at lines anymore. We'll be looking at squares, cubes, and different graphs. So we're going to look at 2.1 first. Okay, and we're going to talk about ordered pairs. Now, ordered pairs always go x, y. Okay? And we plot these ordered pairs on what's called the coordinate system or the Cartesian plane. And for the coordinate system or the Cartesian plane, the x goes left and right, and the y goes up and down. So we plot our ordered pairs on what's called the Cartesian system. Then we can also turn this into quadrants. Okay, so the quadrants tell us where our points are located. And there's 4 different quadrants. And let me just find the page that has it here. This again is out of 2.1. On page 202 at the bottom, you'll see the quadrants. And the quadrants go counterclockwise. And in a moment, we're going to be talking more about the quadrants. We have quadrant 1 at the top, and then it goes counterclockwise, so quadrant 2, quadrant 3, and then finally quadrant 4. So those are our quadrants there. So we've got our ordered pairs, and we've got our quadrants. Now let's go ahead and plot some points. So we're going to plot the following. And let's plot 3, -4, 5, 2. And how about 6, 1? So let's remember how to plot these points. Now again, these are ordered pairs, and they always go x, y. When we plot points, we're not going to connect them together. When we say plot points, that means you just plot the dot where it is. When we say graph, that means we connect them together and either make a straight line or a curve. Okay, so when we plot ordered pairs, let me turn that brightness up a bit. When we plot ordered pairs, I think that makes it a little bit too much. When we plot ordered pairs, we just put dots where they belong. So let's go ahead and plot these ordered pairs. And we're going to begin with 3, -4. So that's over 3 and down 4. 1, 2, 3, 4. So that's my first ordered pair, 3, -4. Okay, so that's our first point. Let's go ahead and plot the other 2 next here. So what are our other 2 points? Well, we've got 5, 2, and that's over 5. So there's 3, 4, 5, and then up 2. So 5, 2 would be clear up here. And what about 6, 1? Well, 6, 1 would be over 6 and then up 1. So it's right here. So that's how you plot ordered pairs. And most of 2-1 should be reviewed. There are some other things that we can do with these ordered pairs. We can find the midpoint and also the distance. The distance is new. Most of you already know how to find the midpoint, but the distance involves square roots. So we'll do the midpoint and the distance formulas, and then we'll come back and we'll talk more about the quadrants. So our midpoint formula is this. Our midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. And we also have a distance formula. We'll use the midpoint formula first, and then we'll come back and use the distance formula. So let's do 2 of these. Let's find the midpoint. And you're going to be given 2 ordered pairs. So how about 3, 5 and 8, negative 4. Now, what is the midpoint? Well, the midpoint is the point that's in the middle between 2 other points. And if you think about it on a map, maps use longitude and latitude. The midpoint would be the city if you're looking at 2 cities. The city that's the closest between the 2 cities you're looking at. So let's say you were trying to schedule a meeting and you want to figure out, well, where would I put this meeting so it's about equal distance between the 2 cities. Midpoint would kind of give you that closest city. And what we do is we add the x's together, divide by 2. We add the y's together, and then we divide by 2. We always begin by labeling our ordered pairs, x1, y1, and x2, y2. So let's go ahead and apply our midpoint formula. And I like to write the formula out several times so that I have it. It's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And if I go ahead and fill in our ordered pairs, we have 3 plus 8, it's our x's, over 2, and 5 minus 4 over 2. You'll want to break this down, if possible, here. 8 plus 3 makes it 11 over 2. That's not going to reduce down. 5 minus 4 is a 1 over 2. And that again is your midpoint. So just think about longitude and latitude on a map. And that would kind of give you the closest city that's in between 2 other cities. We'll do one more of these. This one will have decimals. The next one's going to have decimals. We'll work it out the exact same way. And then we'll work with the distance formula. Okay, so let's go ahead and again find the midpoint. And let's say you're given 1.5 comma minus 3.8 and 4.2 comma 9.3. And I want you to take these 2 points here and then find your midpoint. So what do we need to do? Well, we need to begin by labeling our ordered pairs. We always label them x1 and y1. So x1, y1, and the second one is always x2, y2. Now we can go ahead and apply our midpoint formula. And our midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So plugging in my values, I have 1.5 plus 4.2 over 2. And then I have a minus 3.8 plus 9.3 over 2. So let's go ahead and add these together. So 1.5 plus 4.2, that gives you 5.7 over 2. And then we have a minus 3.8 plus 9.3. That's a 5.5 over 2. And we want to break these down. And we'll break that down into 2.85. And 5.5 divided by 2, well, that's 2.75. So there is your midpoint. And you should already be familiar, hopefully, with this formula from previous courses. But you just simply add the points together and then divide by 2. Now, the distance formula is a little bit more complicated because in the distance formula, we're going to have to take square roots, which means we're going to have to break them down. So the distance formula is a little bit more of a challenge. And the distance formula is this. The distance formula, we relate that or label that D for your distance. And that's the square root of x1 minus x2 squared plus y1 minus y2 squared. This comes from the Pythagorean theorem. So it was actually derived from the Pythagorean theorem off of a right triangle. But let's go ahead now and apply our distance formula. So let's find the distance. And let's say you're given 2 points here. Let's say you're given 5, comma, -3, and 2, 4. So we're going to try and find our distance. I am going to go through this one a little bit slower than I did with the midpoint, because this might be new for a lot of you. When we go to use the distance formula, the midpoint formula, and even the slope formula in 2-3, we always label our ordered pairs. x1, y1, x2, and y2. So those always get labeled. Now with the distance formula, we've got to be careful because we may have double negatives and we've got to square things as well as taking the square root. So I'll always like to write up our formula. So D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And we're going to now go ahead and plug in our values. So that's going to be the square root now of x1 minus x2. So that's 5 minus 2 quantity squared. And then we've got our y's, which is minus 3 minus 4 quantity squared. So take your time with these. Parentheses go first. So 5 minus 2 makes it a 3 squared. And minus 3 minus 4, that makes it a minus 7 squared. Now we can go ahead and break this down. 3 squared is 9. Negative 7 squared makes it a positive 49. And we can add those together, and that's going to make that then what? The square root of 58, I believe. Just like we did with the quadratic formula, we may have to break down that 58. So let's see if we can break it down. 58 is an even number, so let's see if 4 will go in there. No, 4 will not, but I know 2 will, so let's try a 2. Well, that's 2 and 29. And I don't think that 29 will go any further. So in this case, I cannot break down that square root of 58. So I'm going to leave it as it is there. Now, if that would have been something where I could break it down, like the square root of 80, then I would go ahead and break that down. We'll do one more of these. This one's going to have square roots in it already. So we'll do one more utilizing the distance formula. So again, we're going to find the distance here. And you're going to be given 2 ordered pairs. So let's say you're given 4 square root of 3, comma 5 square root of 7. And how about 8 square root of 3 and a minus 4 square root of 7. So this one is a little bit different because it has square roots already in it. Now, if the square roots are the same, they can be combined together. And what happens when I square a square root? Well, that square root just goes away. So we're going to have to put these together. We're going to have to combine the similar roots. And then we'll square to get rid of those roots. And then we'll take the square root at the end. So what I've got is I've got 4 square root of 3 and 5 square root of 7 for the first set. And then I've got 8 square root of 3 and a minus 4 square root of 7 for the second set. Label x1, y1, x2, and y2. So now let's go ahead, write up our formula. So your distance d is the square root of x1 minus x2 squared plus y1 minus y2 squared. And this is very, very similar to question 6 in your homework. It's almost exactly the same, just different roots. So let's go ahead and fill this in. So we now have the square root of 4 square root of 3 minus 8 square root of 3, quantity squared. And then we have 5 square root of 7 minus a minus 4 square root of 7. And that's squared as well. Now, if the roots are the same, then they can be combined together. So notice on our first set of parentheses that these roots are the same, so those can be combined together. So 4 minus 8, 4 minus 8 makes it a minus 4 square root of 3, quantity squared. Now watch out for the next set. The next set, we do have a double negative. And that double negative will make that positive. So now we've got 5 plus 4, that makes it a 9. Square root of 7. Quantity squared. Now what we do is we go ahead and distribute that square through each part of it. With the whole numbers, we'll square those out. With the square roots, well, they're going to go away. So let's look at the first one. Minus 4 squared, when we square a negative, again, that makes that a positive. So that's going to be 16. And the square root of square of the square root of 3, well, that square root goes away, and that leaves you with a 3. Next, we have 9 squared, that's 81. And the square root of 7 squared is 7. Now we can clean this up. So now we've got 16 times 3. That makes that a 48. And 81 times 7. That makes it a 567. And we'll go ahead now, add those together, and then we'll see if we can break down this square root. So we can combine them together. We get a 615. So 615 might break down. Well, 615 ends in a 5. So let's start by dividing out a 5. And that gives you 5 and 123. And I think 123 might go a little bit further into 3 and 41. And then I don't think 41 will go any further because 41 doesn't have a 3 in it. It doesn't have a 7 in it. I don't think it has a 13 in it either. So I can't break that 41 down because 41 is prime. So do I have any pairs that I can take out? Nope, just like using the quadratic formula. If there's no pairs that you can factor out, then everything just stays the same. So what would my final answer be? Then on this one, it would be the square root of 615. Does everyone see how I did that? So I labeled my ordered pairs. I plugged them into the formula. Now, when we square a negative, what happens to it? It becomes positive, and the whole number, 4 in this case, gets squared, and that makes it a 16. When you square a square root, it just goes away. So that leaves you with a 3 there. 9 squared is your 81. The square root of 7 squared comes out to be your 7. So now let's go ahead and talk about the quadrants in a little bit further detail. So let's now look at our graph again, and let's talk about our quadrants. And we're going to talk about our quadrants here in a little bit more detail. So this again is our quadrant 1. Now, if I'm in quadrant 1, what are my signs going to be? Both positive, won't they? Right? Because this is positive x, negative x, positive y, negative y. So if I'm in quadrant 1, that tells me then both of those will be positive. Now, what about quadrant 2? Well, quadrant 2 is back to the left, and we're going back on the negative side. So that's negative for your x component, positive for your y component. What about quadrant 3, down below here? Both negative. And what about quadrant 4? Well, quadrant 4 then would be a positive x value and a negative y value. What we're going to be looking at now is a point in one of these quadrants, and then we're going to change that point, and we're going to figure out where the new point is at. So we need to make sure we know what these signs are. So here's the question. If AB is in quadrant 2, where is negative A, negative B? So we need to figure out where this new point is at. So let's think about what we know about AB. Okay, now AB is in what quadrant? AB is in quadrant 2. And that means my x value is positive. Sorry, my x value is negative. My y value is positive. So AB is in quadrant 2. And quadrant 2 is negative for the x, positive for the y. And so that tells me then that A is a negative number, B is a positive number. We want now to find negative A, negative B. So let's look now at negative A, negative B. Well, what do we know about A? Okay, well, A is negative. And so what happens when we change our sign? Okay, A right now is negative. When I look at the negative A, what does that mean? That means we're going to change the sign. So A is negative right now. So when I change the sign, what does that negative A become? Positive. What about B? Okay, B right now is positive. I want to change that sign because I want to change the sign of it. That's that negative B there. And when I take that positive number and I change the sign, that becomes then what? Negative. Now, where is it? Positive, comma, negative. Where is that at? That would be where? Quadrant 3. So what would your quadrant 4. So what would your answer be for this one? My answer would simply be quadrant 4 then. We'll do 3 or 4 of these. They're not difficult, but a lot of times students just get confused because it's different. It's more of an abstract concept. So let's try another one of these. I'll give you a new point in a quadrant where it belongs, and we'll change that point. So let's say if AB is in quadrant 3, where is negative A, B? So the first thing we need to look at is we need to figure out the signs of A and B. So we've got A and B. And this is in quadrant 3. So how do the signs go for quadrant 3? Well, if we go back up and look here, it looks like in quadrant 3 they are what? Both negative. So we want now negative and negative. So that means that A is a negative number and B is a negative number. What we're trying to find is negative A, comma B. Now, B is not changing. So B is going to stay the same. But that negative A, we switch our sign. So what do we have now? Well, A right now is currently what? A is negative. We want the opposite of A, so negative A. So the opposite of that negative would make it A, positive. And what about B? Okay, B stays the same, so it would also be what? Negative. It would stay the same. And where is it positive, comma, negative? That again is quadrant what? Quadrant 4 again, isn't it? We'll do one more here. If we need to, we can do another one. I think just one more should hopefully be enough. If we need to, we can do another one. But if AB is in quadrant 1, where is A comma negative B? So first off, what do? Well, we look at AB and we see what the sign should be. So we're in quadrant 1. And what do we know about quadrant 1? We go back and look. How do the signs go for quadrant 1? They are both what? Positive. So that means A is going to be positive and B is also positive. Now what we want is A negative B. So that A is going to stay the same. It's not changing. So A doesn't change. So A stays positive. And I should have picked better numbers. I didn't mean them all to come out in quadrant 4. That was just the way that they came out when I picked them. But what about negative B? So A is positive. It stays the same. B is positive, but we switch it, and it makes it then what? Negative. And positive, negative. That makes it quadrant what? 4. Let's try one more, and this one won't come out to be quadrant 4. I just kept picking them where they came out that way. So let's try one more just to make sure we have these down. So let's say if AB is in quadrant 4, where is negative A, negative B? So we've got AB here. Right. So we've got A comma B, and we're in quadrant 4. So what do we know about quadrant 4? Well, quadrant 4 then means it is positive, comma negative. So that tells me then that A is positive, B is negative. We want negative A, negative B. So what's happening to both of these? Well, they're both going to be changing, aren't they? So I've got to change both. So when I change both of them, well, A is positive, and if I change that positive, it's going to become a negative. B is negative, and if I change it, it becomes a what? Positive. Doesn't you change both signs? And where is it negative, comma positive? Well, that would be in quadrant what? Quadrant, if you go back and look, quadrant 2, wouldn't it? So do we kind of see how these are working? You'll identify what the signs are for A and B. Now, we don't know the exact value of A and B, and that's not important. All we want to know is what the signs are. Then we look at our coordinate plane, or Cartesian system, and we look and we see which quadrant it's in, and we see what those signs will be. Match them up. Then we change it. Now, you might change both signs. You might just change one of the signs. The one question that's like this is question 9 in your homework. So this is going to be like question 9. We do have one more quick topic to cover in 2.1, and then we'll take a short break, and that is just how to complete ordered pairs and graph a line. So I'm going to give you an equation. You're going to complete the ordered pairs and graph the line. So how about x minus y equals 4? And I want you to complete these 3 ordered pairs. So how about 1 comma blank, negative 2 comma blank, and blank comma 0. To graph a line, you need at least 2 different points. You can have more than 2, but the minimum to graph a line is 2 points. So I've given you the line equation, and I've given you a partly completed set of ordered pairs. We're going to complete these ordered pairs, then we're going to plot our points and graph the line by connecting them together. So let's start with our first one. Remember, this is x and y. X always goes first. So we know our x value. So in this case, x is 1. So that's 1 minus y equals 4. We'll move that 1 over. And minus y equals 3. Divide by a negative 1. And y equals then a negative 3. What about the next one? Same process. X equals a negative 2. And that's going to be minus 2 minus y equals 4. We're going to add 2 to both sides. So that gives you minus y equals 6. We'll divide by our negative 1. And that leaves you then with y equals a negative 6. And this you should already be familiar with. You should know how to fill in the blanks on these ordered pairs. So this is nothing new. The quadrants was new, and the distance formula was probably new. The rest should mostly have been a lot of review. For the last one, we've got y equals 0. So what are we going to do? We're going to plug in that 0. That 0 cancels out, so we're left with x equaling 4. Now we have our 3 ordered pairs. We're going to plot our ordered pairs and then graph them with a line. These should make a straight line. So let's go ahead now and plot our ordered pairs. On your homework, you've got graph paper. So yours will look a little bit neater than mine. Mine are just kind of difficult to graph because I don't have a piece of graph paper. I'm just using line paper, unlined paper. So let's start with 1, negative 3. Well, that's over 1. And then down 1, 2, 3. So 1, negative 3 is here. Then we've got negative 2, negative 3, or sorry, negative 6, I mean. So 1, 2, 3, 4, 5, 6. And that looks like that's going to be right about there. And then lastly, we've got 4, 0. So that's 1, 2, 3, 4. And that's right there. And that's also called your x-intercept. So we now have our 3 ordered pairs. You only really need 2. We've got 3, so that's more than enough. And now we just take a ruler or a straight edge, and we simply connect them together. And that makes our graph. So there's our graph. Okay, so let's go ahead and take a short break, and let's meet back here at, let's say, about 7:50. So meet back here around 7:50, and then we'll start the next section, which is circles.